Okay, so again, what power is a lead-in to a function we're going to talk about next week? The what power function is asking us what power of 2 is 8? And that answer is 3. And that's because 2 cubed is equal to 8. So I want you to write next to each of these as you find your answer, I want you to write your because statement. Why is that the answer? So the second one says, what power of 3 is 9? The answer is 2, because what? Why? Because 3 squared equals 9. Okay. What power of 6 is 36? 2. Right? Because 6 squared is 36. Okay, so I'm going to let you work on the rest of these together with the person next to you, and then we'll come back and go over them. All right, let's go over these. Number 4, what power of 2 is 32? 5, because 2 to the 5th equals 32. It should be true. My statement over here, my because statement needs to be true, right? Some of you are writing because 5 squared equals 32. Well, that's not true, right? It's the 2 that's the base. With tens, we're counting our zeros, right? 10 to what power is 1,000? 3. Because 10 cubed equals 1,000. What power of 10 is 1 million? Well, this is actually, 1, 2, 3, 4, 5, 6. It's, well, for 6, it's 6. There's 6 zeros. 10 to the 6th, the next one, is 1 million. But what power of 100 is 1 million? Now it's 3, because there's 3 sets of 2 zeros, right? Because 100 cubed is 1 million. What power of 4 is 64? Because 4 cubed is 64. Right? What power of 2 is 64? 6. Because 2 to the 6th equals 64. Now we're getting kind of into the tricky ones, right? What power of 9 is 3? 1/2. Yes, 1/2, because the square root is the 1/2 power. So in order for us to make it smaller, we're going to have to use a root. We're not dividing, so it's not 1/3. The square root is 1/2. The square root of 9 equals 3. And so that makes what power 5 of square root 5 also 1/2, because 5 to the 1/2 power is equal to the square root of 5. What power of 1/2 is 1/8? It's 3. Apparently I didn't finish erasing my answers. Because 1/2 to the 3rd is equal to 1/8. What power of 41 is 1? 0, right? Anything to the 0 power is 1. You have to remember that, especially on your equations. When it's equal to 1, you want to make that whatever base you need to the 0 power. Because 42 to the 0 is equal to 1. And then what power of 100 is 0.01? Well, let's remember that this is 1 over 100. Because that's the hundredths place, right? And so 100 to what power is 1 over 100? -1. Because 100 to the -1 power is 0.01. And lastly, what power of 2 is 1/4? -2. Because 2 to the -2 power is 1 over 4. Okay, so now I'm going to do 3 more examples like yesterday, solving exponential equations, or like Friday. But just want to focus on some of the trickier ones. What if we give you radicals? We have to remember what we learned last chapter in chapter 5, that the square root of 6 is 6 to what power? 6 to the 1/2 power, right? And this cube root of 6 is what? 6 to the 1/3 power. And the 4th root of 6 is 6 to the 1/4 power. So we need to remember this information from chapter 5. And then here's our first example. I'll give you a second to write that down. 7 to the x plus 4 over 3 is equal to the cube root of x, or 7. All right, so our first example. My bases are already the same. I have 7 on both sides, but I need to rewrite the right side as an exponent. The cube root is 7 to the 1/3 power. So 7 to the x plus 4 over 3 is equal to 7 to the 1/3 power. This here is the critical step that we want to box, circle, highlight, whatever, but emphasize on your paper. Okay, what I was seeing as I was going over last night's homework is shortcuts and not writing that critical step before you write your equations, and we need to make sure we're doing that. So now I can equate my bases, or my exponents. X plus 4 equals 3. I'm sorry, x plus 4 over 3 is equal to 1/3. And I can solve that by, I want to get x by itself, so on this side I need to get rid of the denominator. What am I going to do? Multiply by 3. And we get x plus 4. My 3's cancel, equals 1. Minus the 4, and x is equal to -3. Now example 2 uses the number e. Yes, I said the number e, which we will learn about later on this chapter. But it doesn't really matter what that number is. It can still be a base for an exponent. So 1 over anything is what exponent? Yes, e to the -1. 1 over 5 is 5 to the -1. 1 over x is x to the -1. So e to the -1 is equal to e to the x plus 5. And that's my critical step. I can set my exponents equal to each other now. -1 equals x plus 5 minus 5. And -6 equals x. And then example 3, 8 to the x minus 2 to the 2x plus 1 equals 0. On Friday, we looked at if it was equal to 1, we used anything to the 0 power, right? 2 to the 0 or 6 to the 0. You will have to use that on today's homework, making the 1 a base to the 0 power. But when it's equal to 0, we can't do that. There is no number we can raise to a power and get 0. Right? Can you think of one? Anything to the 0 power is 1. Well, 0 to the 0 power, that's not going to help me get my bases the same. So what I can do here is actually move the 2 to the 2x plus 1 to the other side, so that I can then make an equation that I can solve. So I have 8 to the x equals 2 to the 2x plus 1. Now I want to get my bases the same. So I need to write 8 as 2 cubed, because 8 equals 2 cubed. So 2 cubed to the x equals 2 to the 2x plus 1. And this is where I'm seeing a lot of people skip that critical step by not simplifying. 2 to 3x equals 2 to the 2x plus 1. That's the critical step. If you're skipping from here to the equation, you're going to get points marked off for not having the critical step included. Okay? I want to see you simplify the exponents, multiply, use your properties properly. So now I can write the equation 3x equals 2x plus 1. And we can subtract 2x. And x is equal to 1. Okay? So those are just a couple more examples to get you through today's homework.